So, Andrew, it's all yours.
Thank you. So yeah, thank you. Excuse me. So this is cool. Like, I've done this talk before, but I couldn't see the audience. So it's quite nice I can see everybody. So I can see if some stuff, I'm not trying to be controversial, but I might, Neil's not here, so I can say, I might contradict some of the stuff Neil said. So that's my job. Because we both work for the same company. So the whole point of being at Thoughtworks is you don't agree with each other. I think there's a joke, like if you get 7 Thoughtworkers in a room, there'll be 8 opinions. So what I want to do is kind of make you think differently. So I'm Andrew Harmel-Law. My pronouns are he, him, and they, them. I'm not neurotypical, so it made me kind of happy when Neil put up like the spectrum of architectural and design decisions, because I'm on both the autistic and the ADHD spectrum. So as a part of all of this, I kind of find myself questioning and being a thought worker, like not accepting what I'm told, which is, if that's you, then you should come and join Thoughtworks. I don't know if we're hiring, but it's amazing, but that's not a pitch. So what I want to do is I want to talk about, it says up here how we decide. That's the old title of the talk, which I forgot to change. But basically, it's like how you make decisions, how decisions are made in modern software. It's a piece of the book that I'm writing, or have finished writing, but is currently making its way through production. So on the 8th, if I don't screw it up, the 8th of November, there's a whole book, which is pretty thick. Tells you how to do this and lots of other stuff. So hopefully you'll have tons of questions. My idea is to make you see what you do in a different way and kind of maybe use that as a lens to like question how you do things and what you do and use that new knowledge to do things differently. I just caught sight of Abraham. I am not going to mention Gen AI, because Gen AI like just throws all of this up in the air in an exciting and cool way. So Abraham is going to come along afterwards and throw all of this stuff up in the air and mix it all up again. So I'm going to try and stay kind of maybe controversial, but that's good for a Barcelona audience, but like kind of try and draw some lines and tell you what I think things are there. So why are decisions important? The reason decisions are important is all of the stuff Neil was talking about, all of the architectural things or whatever. You could say that software architecture is the sum of all of the decisions that were made to get to that point, right? You make small decisions, you make big decisions, you know, when you're deciding to write one line of code in a certain way or a line of code in another way, or if you're deciding to use microservices versus event-driven systems or whatever. They're just the sum total of all of your decisions. So decisions are really big. I don't think we think about deciding enough, so that's what this talk is about. So let's start with like a really simple, too simple picture of deciding. So if you step back and think about it, and this is all decisions, right? This could be a decision to have a coffee. So I did this talk in Norway, and like the Norwegians are the most obsessed with coffee ever. Pick whatever Barcelona, Catalonians are obsessed with, and you could do a similar thing, right? So if you imagine you're going into, in this example, a coffee shop. So first you think, oh, I need to make a decision. I realize I'm thirsty. I need to go and get a drink. I'm going to go into a coffee shop, and then I'm going to figure out which coffee I want to select, and then I can ask for my coffee, order my coffee, pay for it, and then the decision will be made, and I will be given the coffee. So really simply, if you split this up, it's got 3 stages. So the first stage is figuring out that you require a decision. I realize that I'm thirsty. The big bit in the middle, which I'm going to expand, because it turns out deciding is a bit more complicated than just deciding. You then do the deciding to figure out what you're going to have. That's where the actual work happens. And in software, it's a lot harder than ordering a coffee, even though ordering a coffee these days can feel kind of complicated. And then finally, there's the decision implemented stage. Again, I mentioned that because this is a bit where we were talking at the kind of question corner before. One of the things somebody asked me about was, decisions get made, but then that's not what ends up in the code. So this is important, right? Alberto Brandolini has a quote, which is, what ends up in production is the developer's assumption, not what might have been the decision. So the person who writes the code, that's how it ends up in production. So, before I forget something, So this is naive. Let's make it more realistic. So if we expand the box in the middle, you get, or I think, this is my opinion, this is not scientific. I've read a bunch of books. I've got a psychology degree, but this wasn't covered in my psychology degree. But if you split it open, you kind of get these different pieces. You get 2 bits that definitely happen, and you get 1 bit that might happen when you're doing deciding beyond yourself, right? Because you still make decisions in your own actions, but as soon as you're deciding with other people, like if you're in a coffee shop, then the third part becomes important. So the first thing is option making. So in the coffee shop example, you go into the coffee shop, you've always got option 1, which is these coffees are incredibly expensive, Starbucks has ruined the universe, and I'm just going to leave. So the option 1 is don't buy a coffee. But all the other options, you need to figure out what those are, right? Starbucks have made this difficult, so you have to watch the moving screen for like 10 minutes before you can find out all of the options for coffee. There's also a bunch of stuff you can order which they don't seem to list on the menu anymore, and there's 100 different options that you can combine to make your coffee, right? So I've called that option making. You're making the list of options that you care about. You could do anything in Starbucks these days, right? Or any other coffee shop. But you're making the options for you that suit your circumstances. Then you take the decision, right? Based on the 3 things you think you might have, you pick the one you want, which could be super quick, or if you're indecisive, could take forever. And then, because we're in a coffee shop, me thinking I'm going to have like a tall Americano with oat milk, if I don't say that out loud to the barista, it's not going to happen. So I then need to tell the barista who asked me my name, they write my name down wrong, and then they make the coffee. And then the decision gets implemented. Again, they might make the wrong coffee, or I might explain it wrong because my Spanish is terrible. Millions of things could happen. But all of these things are kind of the bits along the way. That's just ordering a coffee, right? If we think about doing this in software, everything gets more complicated. For starters, there's probably a right answer to ordering a coffee. I can probably pick something which I would probably like the most, and I can probably get something, right? Whereas in software, any decision that's significant, and this is where I might first disagree with Neil, I think you can make significant decisions at a very small level. It's just something you might not realize is a significant decision. For example, upgrading to Spring to another minor release, which turns out to break everything, or like brings in a transitive dependency, which nobody knows about, and suddenly 3 years later, you've got a gigantic security hole in your system. All of this stuff can happen. But so this is kind of hard stuff, right? Software architecture problems, or just decisions in software, are what are called wicked problems. There is no right answer. It's probably why lots of us work in this career, because we love to debate things. We love to have very strong opinions. We love to tell everyone what our opinions are. Sometimes it feels like we like talking about our opinions more than we like writing code. But this is the thing. So software is hard, right? But this is the kind of the view that I'm going to use to think about different ways of deciding. Because however you decide, you could roll a dice for like decision taking, right? Or you could pick the top one, or you could pick the one that you feel best about, or the whatever. This is a standard way of deciding. What I want you to do is, because I'm going to take this standard framework of thinking about decisions, and I'm now going to bring that up to deciding in circumstances where there's more than one person. Because again, very few of us write code, unless you're doing your own personal open source project, right? Even if it's you plus someone else, there might be other people involved in the decision. So how do we scale this decision process? How do we approach this decision in a way that we bring in the right people to do the right decision? So what I want you to do is think about, because I'm going to list out the standard ways that there are to make decisions, so you can then hopefully spot them at play in your company. And I can guarantee nobody will have them in the kind of clean, crisp way that I describe them. There'll probably be a big mix. But the idea is that you'll get an idea of how these decisions might be, and then you can kind of be aware of your decision process. So the 2 things I want you to pay attention to, because I will then evaluate them, and then what I'll do is I'll talk a little bit about modern software development, because things have changed in how we write software. The stuff, for example, to do with Gen AI is coming along. but also lots of the stuff that Neil talked about, like architectural systems evolve and all this kind of stuff. Everything is changing, so we need to be aware of how we decide in the changing circumstances. So then I'll take this and I'll apply it to those circumstances. So the two things to think about are, number one, who has the power to decide, the bit in the middle, but also who has the power to start a decision? Because both of these have power. So this one, that's the one first. But also, who has power in option making, right? Because we think that lots of the power sits with the decision taker, right? Like the CTO or the chief architect or whoever. But there's also a lot of power in the making of the options, like coming up with the designs, which are then kind of selected between, right? Maybe you only come up with one design because that's how you work, but that's still, you're making an option and then you're deciding to go with it, right? So pay attention to that. The other thing I want you to think about is, as we go through all of the different approaches to decision making, think about speed. Like, how fast could these processes be? Because we're building software, everyone wants us to go fast, nobody wants you to build software in a slow way, product managers definitely don't want us to wait when we could make a decision today and then write the code tomorrow and push it into production, right? So speed and who has the power to both decide but also initiate, the power to decide that a decision needs to be taken. So these are the 6 different approaches that I'll talk about. You might have heard of many of them. I'll be quite clear on some of them, because it turns out when I wrote the book and I got feedback from lots of people whose first language wasn't English, some of these things mean slightly different things to different people. Like Greeks have a very, very specific idea of democratic processes, for example. These aren't all the approaches either. These are just the ones that you see the most. So there's also the avoidant decision process, which is we'll try and not make any decisions for as long as possible, and then hopefully the universe will decide for us, right? Which is, it's not a good strategy, but it's a strategy that people use all the time, right? But there's also these other political kind of ways of deciding, which again, I'm sure actually Barcelona and Catalonia is probably some from Scotland, quite aware of all of these different ways of making decisions in large groups. Again, I don't cover those because they're not typically used within software. But I take inspiration. I've spent a lot of time reading about lots of different things like citizens' assemblies, and there's a German hierarchical, because God bless Germany, there's a German hierarchical way of decisions migrating to the right level of a hierarchy. You could use them, but I don't talk about them. So I'll start with the centralized models. So the first centralized model is the autocratic approach. So the autocratic approach is where there is an autocrat, which is this person here. The autocrat has complete control over the entire process, right? So just like you would think, the autocrat is the person who's doing the option making, they're doing the decision taking, and they're sharing the decision, because if they don't tell everyone they've made a decision, then it's kind of useless, right? Because the rest of the team, or the rest of all of the teams, are the people making the decision, right? So the key things to bear in here are, actually, let's have an example. The good example is a new chief architect joins, they hate Amazon Web Services, they love Azure, so they decide in the shower that everything's going to flip from AWS to Azure. Possible. I've been with clients where certain decisions like that were not inconceivable. So therefore, remember I said, think about how fast things are and how where the power lives. The power completely lives with this one person, but it was quick. They didn't even finish their shower before they decided to do this massive change, right? So that's good if speed is something you want to optimize for. The problem is, maybe the reason they like the color blue, so that's why they chose Azure, right? It's got nothing to do with Amazon, or they heard a rumor that one of their friends said that Amazon was expensive and AWS was expensive and Azure was cheap, right? So there's no guarantee that this person had access to all of the right information. They might have done, but it's kind of coming from one source, right? So that could be kind of risky. The other thing is, and I'll talk about this later in a minute, if there's one person making all the decisions, like one chief architect or whatever, As you move to more modern software architectures like microservices, et cetera, the whole point of that, and continuous delivery, continuous deployment, the point of that is that you can go fast. If all decisions, big ones and small ones, have to go through a single person, they'll become a bottleneck, right? Maybe it's a good bottleneck. So I'm not, all of these, there's pros and cons to all of these things, but that's the thing. So the next model is delegation. So this delegation model attempts to solve some of the key problems in the autocratic model. So in this case, the autocrat, or like the person who has all of the power to initiate decisions and to take the decisions, realizes they really don't know enough about Azure or AWS, because the last time they heard about it was when they got paid to go to Las Vegas and have a lot of fancy food and wine, right? So they know they're out of date. So they say to their chief infrastructure person, right, or the person who's head of the terribly named DevOps team, but should be called SRE, you do some analysis, you figure out what we should do. So that person then has the delegated power from the autocratic person. They can then make the options, take the decision, and then share that stuff. So by selecting someone who's expert in this area, it's probably a pretty smart idea, right? Because this person probably lives in this world day to day. They probably get the emails from Amazon every 15 seconds telling them that there's a new API which does something completely crazy. All of this stuff, right? So you potentially mitigated some of your problems. And then you still have the rest of the people implementing the decision. So therefore, it's a lot potentially slower, because the autocrat needs to identify who to do it, and they then need to provide the context of why they think the decision is important to this person. But then the quality of the decision, like the appropriateness of the decision, might be better because that person might know a lot more about the decision. And you could potentially delegate lots of different decisions to lots of different people, so you maybe remove the bottleneck, because different people like a team architects or whatever, or systems architects could select things in their teams and stuff as well. So, the third one, which is still a kind of centralized approach, it still comes from this autocrat who's at the center of things, is called the consultative approach. So again, it acknowledges some of the problems that the autocratic approach has and tries to deal with them in different ways. So the consultative approach is the autocrat doesn't give away the power to make options and to take the decision and share it, but they do go out and actively consult with the people who, as far as they're aware, have all of the information, right? Which is good, so they could say to these people, please tell us what you think. So for example, in this example, where they're wondering about the suitability of the cloud platform, they might consult with people in the infrastructure teams. They might consult with people in finance who might have some FinOps data about how much they actually spend on the cloud platform. Maybe people in product management who might have an idea of what the kind of the customer value of all of this is, and maybe even some of the leads of some of the teams or architects, systems architects that work in the teams, to say, which bits do you like, which bits don't you like, where does the value sit, and all of these things, right? So you can bring all of these things into the decision. The key thing about this is, because the autocrat has not given away the power, any of their power, they're just bringing in people for their advice, they don't have to listen to any of this stuff. The development leads or the architects in the teams might tell them a load of stuff they don't want to hear, and they could just completely ignore it, which obviously never happens in real life. Like, you complain a lot and then everyone just ignores you. They can completely ignore it because they maintain the power to do it, right? Good autocratic decision makers wouldn't, but they're not obliged to, right? They retain all of the power. There's another problem which might happen. The person who identifies these experts is the autocrat. So if there are people who are expert, but the autocrat doesn't know they exist, then they might not bring them in for advice. Another thing is obviously selecting, finding all of these people, making sure they have enough time, giving them all of the context, listening to all of their stuff, takes longer. So it's a lot longer than being in the shower and deciding that you're going to swap from AWS to Azure, which is potentially bad, right? So that's that one. So let's quickly summarize, because there's some key points. And so to be very clear, I've never seen anywhere where it's this explicit, right? You see this implicitly all over the place, where certain decisions are made by certain people in certain ways because it just works, and this is how we work in this organization. But these kind of patterns appear, and sometimes they're a mix, and sometimes politics gets in the way, and all of this kind of complicated stuff, right? But fundamentally, these are the standard models. And they share, because they're centralized, they share a few key things. The first thing is they're focused on a single named individual. So in software architecture, maybe there is a set of 4 or 5 or however many named architects, right? But they're the people who are named in the hierarchy in the organization who are responsible for this stuff. So therefore, it's potentially very fast. All of them are pretty quick. You'll see some in a minute, which are potentially incredibly slow, right? So I'm not saying these are bad. They are what they are. The key thing and the biggest problem, especially when we look at modern architectures, which we will after we've covered the next 3, when you look at modern architectures, the power can't move. The power is always with the people with the word architect in their job title. Maybe the architects have enterprise architects and systems architects. And maybe there's a hierarchy of architects, but there will be, those people will be the people who have to say yes or no to stuff. And that means that what you've done is you've achieved speed, potentially. If the architect is really bad at making decisions, then the architect might deliberate for 3 years. But potentially it's fast, but nothing is decentralized. Everything has to kind of go through this centralized point. So that's the centralized approaches. But there's also decentralized approaches, right? Because for all of the reasons you're probably thinking some of these suck, because you've probably seen these weaponized against you, either if you're an architect or if you're a software developer or a lead developer or whatever, you've probably seen these things go wrong. So there's these alternatives, which are decentralized approaches, which I'll cover now. So they still sit in the same kind of general framework, but they work in different ways. So the first one is the consent model. So the consent model, there's still one autocrat or one person who's decided the decision is required, and then they go and do the work, right? So they make the options. They then decide to take one of those decisions. They select one of those things, right? So instead of going, so a good example here is there's a bunch of new microservices that are going to be written because that's what we do. We go to a conference and go home and decide that we're going to rewrite everything in microservices. And so the decision here is what language will we use to write those microservices in? And so, because it's the consent method, the architect who's decided to do this has decided that Java 17 was a pretty nice language, which is the last time they wrote Java code. So Java 17 is one of the language options, or COBOL, because they used to write COBOL, and that was also probably a good language for writing microservices in, plus Node.js, because they were speaking to their kid, and their kid said Node.js is what all the cool people are doing stuff in, right? So they're like, okay, these are the 3 options. But they select, because it's the consent model, they select Java 17 because they're most comfortable with it. So then they ask for consent to this decision by all of the people who are kind of gathered to be able to consent to that decision. So in some circumstances, I've seen this as well, it's everyone in the technical organization. Sometimes it's all of the team leads. Sometimes it's just all the other architects or whatever. That kind of, the nature of that, it just depends on how the organization is set up. But the key thing about consent is you can say yes or no. So if I think it shouldn't be Java 17, I think it should be Java 18. I don't say Java 18, I say no. Right? And based on the consent model, if one person says no, if everyone doesn't consent, then it doesn't get passed. And then it needs to go back to the drawing board, and whoever is proposing the decisions, proposing the way forward, has to go back and come up with another option. So you can get different flavors where it might be like 80% people have to vote and all of this kind of stuff, but typically the standard way is like if one person has a complaint, then you stop. So what's happening here is there's a considerable power shift, right? Because the power, the crown that was sitting on top of decision-taking is now kind of like beginning to be shared, right? The decision initiation is still happening in one place, but like who can decide, the ability to say no is like a big deal. So if you study history, like this is where, like for example, in this Magna Carta in the UK, which is a very old document, but basically it was where the king, because they'd, I think, had too many wars, they needed to like get buy-in from all of the barons. So they said to the barons, you can say no when you don't want me to do something. So they signed it, and so therefore they got a veto of stuff. So it happens in history. And then eventually you go back around and around the loop, and then eventually you pick a solution which everybody thinks is good, and then you go forward, right? This, therefore, can grind things to a halt. Like, you see this, I see this all the time. People are like, we all decide, apart from that one person who has this power in the organization which nobody quite understands, but they're the person who knows how to implement that one SQL stored procedure or whatever, so therefore they get to vote and say no. So this stuff happens all the time. So consent is one way, but there's other ways too. The next one is democratic. So democratic here doesn't mean, it's like the Athenian version of democracy, where you aren't voting for a representative to go to the parliament to decide for you. You are literally voting on everything that comes through, right? So the Athenian direct form of democracy, which is why Greek people were like, this is kind of cool. So same thing, decision required is identified by the person, the autocrat, or the person who's doing decisions. They make the options, but instead of selecting an option and then presenting that selection to the team who then say yes or no, they let everybody vote, right? So they make the list, and then people vote. So they're still doing the option making, and this is, like I said, the option making still has a lot of power. It's especially powerful in these kind of circumstances because you can direct people in certain directions, right? If you just think that Ruby on Rails is a disaster and should never have been created as a language, which I don't think, but if you did, you could just not put it on the list, and then despite the fact everyone else thinks Ruby's amazing, you could not put it on the list, right? It's not on the ballot, you can't vote for it. So then you open it up to option A, option, and everybody votes. This is good, apart from a few problems. Number one, you end up kind of selecting, and this may or may not have happened in political elections in various parts of Europe and the rest of the world at the moment, you end up with probably the least bad of all of the choices. So you don't end up with an awesome selection, you just end the one which offends most people least, right? So you'll probably end up with Java, and I am a Java developer, so it pains me to say this, but you'll probably end up with the language which most people hate the least if you're selecting a language, right? The other thing is, voting kind of disenfranchises people who might have a very good opinion and a very valid set of concerns about something, but it silences them because they might be a small minority, and yet the fact that you've just recently hired or acquired another company or something, and they have very strong opinions about Kotlin, but there's only 4 of them, so their votes get completely lost in all of the noise. So it's not bad, but you lose minorities who might have a really important vote or important voice to say. It also gives people the impression that because we let everyone vote, obviously everyone buys into the decision. Not everyone in Britain, for example, is massively happy with what happened in many of our recent elections, but we're just less unhappy than everything else, right? So the last one, the third one, is what would happen if we just completely opened up the doors and we let everybody work with absolutely everything. So that's consensus. So consensus involves the selected group, which might be everybody, or might be all the tech leads, or all the architects, or whatever. But whatever the group is that's been selected for deciding. The option making is now open to everybody, and the decision taking, right? So this can be amazing. You can get all of these, assuming that you've got kind of a safe environment and people feel comfortable sharing their opinions, etc., which is not always the case. But assuming that that's the case, you can get maximum involvement, you can get a really beneficial mixing of everybody's experience, and you can get really, really good decisions. The downside is this can take forever. Like, I've been in companies where everyone has a strong opinion, but they can never come to a consensus, because consensus means that people need to trade off ideas and stuff, and as software engineers, sometimes we're not great at doing that. And if it takes so long, I've been at places where everyone's deciding which version of Java to use, by which point a new version of Java comes along, and then the whole discussion opens up again, because there's a new version of Java, so we should stop the old one and start the new one. So that's good. So power's leveled out, but it can be painfully slow. So that's the three ones here. There's other ones, again, like I say, there'll always be a mix. Politics I've completely ignored, but like, human beings saying, if I vote for you, will you vote for me? Or I'm scared of that person and they do my pay review. I'm ignoring all of that. All of that plays into this as well, but let's not make it too complicated. So, what are the key factors about decentralized approaches to deciding? Number one, the power is spread wider, right? Specifically, the power to make options and take a decision. They get spread wider and wider. And it's spread wider because increasingly larger groups are involved and are able to block a decision, right? Or contribute to a decision. Therefore, they take longer. So what you get is decentralization of control, right? Which again, decentralization seems like a pretty cool thing to do, so then you can get the collected expertise of lots of people, but it's typically at the expense of speed. None of this is ever going to be as fast as an autocrat in the shower deciding, based on no evidence, that they should move from AWS to Azure, right? Which hasn't ever happened on a project with me, but wouldn't be surprised. So with all that in mind, now what I want you to do is put this into modern software development. So there's two key things about software, and specifically about decisions. The things you need to think about is who has the authority for a decision and who is accountable for the decision. So when you really boil it down, and I mentioned the quote from Alberto Brandolini, the key thing with software is in architectural decisions. If it gets into code, if we decide to use Java 17 but no one writes any lines of code in Java 17, it's not really happened. So it's the people who put this into code that have ultimately the authority to do things, right? But the accountability is the person who's responsible. So there was a big court case in the UK recently where an IT system for the post office had been not working as it was intended, and the people who were accountable were very different from the people who were actually writing the code. And there was loads of testimony in court from architects and all of these kind of things. So thinking about who has authority and who is accountable is super key. So let's, with that in mind, think about these two things. What does modern software look like? In an ideal world, if you're practicing DevOps, you're practicing continuous deployment as per the book by Valentina Servile, my colleague, that just came out a few months ago. You're doing continuous deployment. You're doing cloud-based environments, you're doing product-led development, you've got independent teams because you've read team topologies, you're doing all of the cool stuff, right? In an ideal world, you have a lot of teams trying to move really fast, independently of each other. So autonomous teams is a bit of a bad word, because autonomous means we don't care. These teams are still collaborating to build an overall system, right? So they're not autonomous, but ideally they're independent because they can release their software without having to have a big meeting to agree that everyone else can release. They're self-managing and they're self-sustaining, right? They know what the value of their software is, they know what they're doing, why they're doing it, et cetera, et cetera. So this is what you want if you've read all the books, right? But then you've got to make decision after decision after decision because you're building software. So there's two memes for the old, traditional, standard ways of doing architecture. So the first meme, this isn't true. This is the Ivory Tower architect. I've been an Ivory Tower architect. And no one who is an Ivory Tower architect likes being an Ivory Tower architect. Because for starters, it's never an Ivory Tower. It's like an office just like everyone else, and you still sit at the same desk with the same people. But decisions go to, in the Ivory Tower model, which is a bit of a cliche, but the decisions go to some group of people or an individual, and then they follow one or more of the processes that I shared, or a mix, or whatever. Right? That's one model. The other model, which I then tried to do after that, is the hands-on architect, which is how I try and be an architect, or used to try and be an architect. But the same thing is happening, right? Because there is still typically, in most organizations, the fact that someone needs to sign off the decision, and it's typically that person. So the hands-on architect is probably aligned to one or more teams, and you run around trying to take those decisions, right? So it's still stressful. You don't live in an ivory tower, which didn't exist in the first place. You're just running around a lot, drawing pictures on whiteboards, or maybe on Zoom, not on Zoom, on Miro or Mural or something, on Confluence. Sorry, Jackie. But so these are the standard ways of doing it. But there's still, all of these 6 different ways of doing decisions are still being kind of selected by these 2 approaches. So based on that, what might you want to do? So, and we'll do this quickly, because I put everyone to sleep last time I went through this. If we plot the things I've talked about before, and so this is, I got feedback about this last time. This is my opinion. Other opinions are available. This is my opinion of where these things sit. This is the best they can be. If you have like an autocrat, but who's indecisive, then it will be centralized and slow, right? But we're assuming that it's an autocrat who's amazing at making decisions, right? They can decide 17 things before breakfast. They go to work, they make 300 more decisions, and like stuff's happening, right? Consensus, we're assuming it's like everybody's involved, everybody, even the junior developer who joined 3 weeks ago, right? But it's slow. So these are kind of like the optimum places things can be. There's 2 things to notice. There's nothing in the bottom left because nobody wants a slow, centralized process. So if you're down there, and this is where like my spidey sense kicks in, lots of people live down there because everyone's trying to figure out the perfect architecture. Again, the perfect architecture doesn't exist, especially if it's in people's heads and it's not running in code. So the key thing is, and it triggers people in my book, but there's a section called slow and wrong is better than fast. Fast and wrong is better than slow and correct, which is a quote from Don Reinertsen, who wrote the Principles of Product Development Flow. His key thing is if it's a perfect decision, which we've already said, or I've said, doesn't exist because it's software architecture. If it's the perfect decision on Confluence, but it's not in code, it's irrelevant. But if it's wrong and it's in code, we can at least try and fix it. So that's the point. But also, there's nothing in the top right. So does that mean the top right is impossible? Well, let's have a quick think. First thing is, and I've talked about this a little bit, what makes a process fast? Because if teams are independent, right, and they're trying to move really fast, you want a process that's really fast to respond, right? So the one that's fastest is the autocrat making decisions really fast. The one that's slowest is where everyone's involved. So the key factor here is, I would argue, the number of people who are involved in any single given decision. So it's the number of people who can contribute in some way to that decision, right? So optimizing for that is clearly important. If we look at the other axis, what makes a process decentralized for decision rights, the thing that makes it most decentralized is the more people who can have an influence on the option making and the taking, and, which I haven't mentioned, but I'm going to come back to in a second, even the ability to initiate a decision, the more people have the ability and the power to do that, that's how decentralized you are. But everything I've talked about so far, the people who traditionally have the word architect and who are traditionally responsible, so in the case of the UK with the post office, the person who would have to go to court and testify as a witness and say, this is what happened, that would be the architect in both the ivory tower and the hands-on approach, right? So it's decentralized based on how much involvement people can have in these things. So that's cool. So you can probably guess I'm trying to push this out so that things can change and we can put something in the top right. But the other thing is like, I've mentioned this court case in the UK. You do need someone to be accountable for software decisions, right? We build software that's incredibly powerful, that can do very powerful things. Elon Musk is currently trying to destroy Western democracy based on some of the technical decisions he's making. So we can write very little pieces of code that can have massive impacts on society, right? So you do need people to be consciously aware of things, right? So my challenge is, how do we do that? It's not just me that thought about it, though. What do we want to do? The thing that we want to do is we want to have the right people making the right decisions in the right place at the right time. Sometimes those are decisions just for one team, right? Just my team, we're using a separate language, we're completely isolated, we've got our own build pipelines and everything, it's completely isolated to us, right? Other times, like you might be using micro front ends, there's a shared infrastructure, so therefore if someone decides to change something about the micro front end architecture, it might break everyone's stuff. So some things are cross-cutting system level, some things are not. So knowing where those decisions are, you can write an entire 17-chapter book about, so you can download that at the end. But so there's different decisions. So what you want to do is have the decision authority and responsibility in the right place. So this is where we come back to who has authority and who's accountable. It turns out that OASP, which is the Open Architecture Group, the people behind TOGAF and associated with all the kind of large-scale architecture frameworks, they've been worrying about this too, right? Because they saw agile coming, they saw DevOps coming, they saw all of these changes, lean product development, etc. They thought about it, and they said, the key thing is to align decision-making authority with accountability. So as long as the person who like puts the code into production, or who makes the decision that then gets put into production are aligned, that's the way to do it. And so therefore, if you have different scopes of decisions, then it needs to work in different ways. So the question is, how do you do that? So I've got 1 minute left, and I'll tell you about the way to do it. And if you want to know more, there's an entire 17-chapter book waiting for you to read about it. But the way to sit in the top right is to use what's called the advice process. So I am very strongly not suggesting that everybody do it, because it depends on your circumstances. But being someone who's tried this in many different clients, with many different cultures, with many different backgrounds, many different architectures, many different like legacy stuff, large companies, small companies, many different varieties. When you set this up well, it works incredibly well. So the way you do it is, the rule is anyone can make any decision, right? But that sounds crazy, so how do you make sure that that doesn't turn into complete chaos? The way it stops turning into chaos is there are two caveats to that rule. The first one is you must seek advice. So not permission, advice from everyone who will be affected. So if I'm going to change something about the microfront end, I need to seek advice from all teams who consume the microfront end core, and they tell me this will break all of our stuff, don't do it. I can ignore them, but I'm going to be the person who writes the ADR, which contains the advice from team A, which says this will break our stuff, and then I take a decision to ignore them. So I'm responsible for being a jerk. It's my responsibility. Also, people with expertise, because if you just get people who are affected, you miss out on people who might have done it but moved team because they couldn't cope anymore, being in the team which from the receiving end of all of this stuff, but there's someone who knows tons about microfront ends, but they moved to be a DBA, so you still go and speak to them because they probably know a bunch of stuff. Or you speak to regulatory because it's something to do with banking. Or you speak to UX or product or whatever. You bring in the right people. So the key thing is the person who's initiating the decision thinks about what they're going to do, brings in the right people, and then the decision gets options made and decision taken like that. And that's how it sits up there. So it's both fast and decentralized, assuming the skill of doing software architecture is spread appropriately through your organization. And that's why my book is called, I think this is the thing, if I zoom forward actually, that's why my book is called Facilitating Software Architecture, because the ironic thing is, with the new architectures that we're building, with the cloud, with all of these different approaches, architectures, technologies, patterns, everything, we can go faster, but that means we need more software architecture, not less. That's why the old way of doing it, the ivory tower wasn't broken forever. The hands-on architect wasn't having a hellish job forever. It got hard because there was more teams that were more independent and wanted to move more quickly. So all of those forces of software have come along and made the job of architecture hard, but it's made the job of architecture more important. Because if you're not able to react and respond, you'll get the mess, the big ball of mud that Neil talked about. So I'm not saying all of the stuff that Neil talks about is relevant. I'm just saying be conscious about how and why and where you approach it, because it's super important. And if you get it right, it's a joyous experience working with your code and shipping your product and building user value and all of these things. If you get it wrong, you hate yourself and you wish you hadn't decided to do what you did. So thank you very much.
Thank you, Andrew. We have still 5 minutes left, so there is some space for the questions. Are you ready?
There you go.
Yeah.
Oh. Quick.
Okay, so very first question, what about the quality of decision in these models?
That's an awesome question. So, number one, it's impossible to know if your decision is a good decision or a bad decision until it is running somewhere. So this is why, and this is why I stole it from Don Reinertsen, an ideal product spec, but which never gets turned into a product, if it hasn't been validated, you don't know. So the key thing is good decisions are important, but what you want to optimize for, and I've taken tons from Don Reinertsen's book about this, what you want to optimize for is small decisions which can be put into production rapidly and learn from, which is exactly the same as all the stuff, why cloud came along, because we can put stuff into production, why product and lean thinking came along, why DevOps thinking came along. Because the key thing is that tells you, I've, in the past, and there's stories about this in the book, I've made decisions which I thought were perfect, and they turned out to be horrific. I've seen decisions which I thought were disastrous, but because I was doing the advice process, I was advised I couldn't tell the team to stop, and they turned out to be amazing. You can't tell until it's coded up, right? That sounds like I'm being reckless. The thing that checks the recklessness is you get people to write down an ADR. So if someone is going to take what looks like a kind of maybe not first choice type decision, they're responsible for writing an ADR, and it's them that's accountable for it. So therefore, if they just are doing it because they don't care about anyone or any of the consequences, their name is against the ADR. So that checks people's recklessness. So, and they're still there. So you don't want to just do anything, but get the code into production. That's what you want to do.
It's a good way to measure it. Any good approach to review decision after some month and collect feedback?
Oh yeah, this is right. This is good. I had this. I can't remember if I wrote this into the book. You can totally. This is the best. So ADRs are great for helping you make decisions. So I've got a whole chapter, chapter 6, where people I talk about how writing an ADR helps you make better decisions. And then there's another chapter about ways of thinking and how to be creative and how to define different parts of the ADR to help you make better decisions. But that's only one part of ADRs, right? ADRs are a point-in-time snapshot of a decision. You shouldn't go back and change an ADR. The ADR is like a event log of the architecture, right? It's immutable. Don't go back and change it, but you can totally go back and read it. So if a new person joins your team, you can say, here's all of our ADRs, but we recommend you read this ADR, this ADR, this ADR, and this ADR, because it explains why that part of the code base sucks, why this part of the code base doesn't look like it makes sense, but this is where we're going. All of these things. And the last thing, just like the questioner asked, you can learn stuff. You're like, are we reckless? Are we making too many decisions? Are our decisions too slow? How long did it take us to make a decision? You can do the 4 key metrics for decisions. So you can look at the number of decisions, how long it takes each decision to be taken, so deployment frequency and lead time for changes. You can also do failure things, so how many decisions get superseded or redone or whatever, which is the change failure rate and the mean time to recovery. You can totally look at that stuff. And I've been on clients where this really took off. So the architects suddenly had time, and this is what architects want to do. Like a system architect wants to see how the knowledge system, which is the socio-technical system of all of the human beings and all of your code working together, you can step back and see all of this stuff, right? You can look at the long tail. Why do some decisions take 3 or 4 months when other decisions take a week? You can see. They're too big, or they involve this component that we're all terrified of. Or anything that has to go to finance never goes fast because the finance people never sign off. You can see all of that stuff. And then, as an architect, you can go and change the socio-technical system, right? Which is what architects are good at, right? They can make sure the right experts are available. They can make sure that that the organization understands. They can make sure that the 2 product managers who are constantly at war are confronted with the fact that they're constantly at war, and they can have a big debate between themselves instead of getting their dev teams to have a proxy battle between them, which may or may not have happened in the past. So yeah, that's when you get this data source, it's amazing.
Great. And the last question, it's about the meritocratic approach that wasn't actually on
which
the list.
one?
Meritocratic.
Oh, meritocratic. Yeah. So meritocratic is interesting because who defines that people have merit? Right? Who defines that someone is better placed? So there are explicit stories about this in the book because I'm a male, middle-aged, white architect. So I'm self-selected to believe that my decisions are better than everyone else's decisions. I've been proven wrong over and over again. And there's a quote from an ex-colleague called which is Code Wins Arguments. I've learned, like I offer advice, very strong advice, but I love the fact that people don't need to follow my advice. So I can be very clear. Sometimes I'm right, which is quite nice for my ego. Sometimes I'm wrong, and I can learn, like I thought lambdas were. There was a reason I thought lambdas sucked. It turns out they'd fixed that 3 years before. So then the team went and built it, and they did a bunch of stuff, and it was good. So then I could go and learn and see the implementation and update my understanding and knowledge. So meritocratic is hard because how do you know? But what you want to do is identify the experts. There will be people who are good at being experts. And what you want to do, again, if you're an architect, and there's chapters in the book about this, teach them to be better at giving advice. So there's a whole piece on not just sharing Java is slow, don't use Java. Why is Java slow? So you want to teach those people to remove their ego from their advice and to say, these are the reasons why this is a bad idea, which maximizes the benefit of all of this input and feedback you get. And suddenly, the knowledge that's hidden inside the heads of 2 or 3 people gets spread around, and it gets written down on ADRs. I've seen it at clients where they were scaling up, and there were 2 or 3 architects who knew everything. They just wrote stuff down, and it became this massive treasure trove of information. And suddenly, decisions generally got better because the people who did know everything had shared that information. So it's super cool.
Thank you, Andrew.
Yeah.
Big applause.